Hello everyone, welcome back. So in this video, we are going to understand a very important question from the Leetcode is this. Okay. So question is we have is diagonal traverse. Okay. So we have to work on this one. If you understand this problem, so this problem says that we have given the matrix we have given, right? And all the elements we have on the cell, and we have to return all the elements of the array in diagonal order. Let's suppose, as you can see, very first we have to return 1, then once we reach here we have to revert back the diagonal because initially we go like this, right? Similarly, when we reach here we'll reverse back like this. You can say it's a kind of uh, zigzag path, right? Or once we complete one diagonal we have to flip the direction, you can say, right? Whenever if we'll take this direction in the flag form, this is a direction, right? So we have to take the direction 1, right? When we are going for the upside, and when we are going to the back side, we'll say okay, we'll reverse the direction, we'll flip the direction, right? Either you take 1 or 0, okay, or 1 or -1, right? So this is what we have to take in the direction wise. So we can take 1 and 0 because this is true and this is the false condition. Okay, so what we have, our intuition. So as we know, give me 1 second. So as we can see here, right, if we say the very first, when we first time we traverse like this row, so we can say we will make the upright directions and we'll get the element over here. What is the element is there? This is 1. Then when we reach here, we know that we have to flip the direction. So when we'll flip the direction, we have to move in this direction where we'll get the 2 and then 4. And so we have prepared 2 and 4 when we'll go for the downward left, right? As you can see, from downward left we can say, right? We're going. Next, when we'll reach here, we'll get the next upward directions, right? As we know. So we'll go the upward direction and we'll create 7, 5 and 3. Similarly, we'll reverse the flip directions and we'll reach here and we'll get the another 6 and 8. And in the last, we will go upright and we'll get the 9. I hope you understand this part, right? So if you talk about the intuition, we have two directions are there. One is upward right and one is downward flip, downward left, right? We can say, as you can see here, these are the upward directions and there is two directions are there, that is down left, right? So in the case of when we are going for the upward directions, we assume that this direction is 1. If the direction is 1, right, we will assume that this is the upward directions, right? Upward right. And when we go the down left, we'll say we'll treat it as the direction is 0. So when a boundary condition hits, right, beyond any edge, let's talk about the edges. What are the edges there in the case? So these are the edge conditions, right? We know that when we for in the case of this one, right, what is the edge conditions are there? When we go for the up directions, right, you see that there is no more element is there. There is 2 element, there is 3 element, right? There can be 2 element, right? Like that we have. So we say, so for each direction we are moving upward or downward in the directions, right? There could be a two directions and there can be our boundaries, right? So beyond any edge, we can say we'll go to the update the start. Let's suppose we'll start the update the start and we'll point to the next available cell either at the bottom or the right or the along the edge. And we see that it means what? We want to start the position. Let's suppose if we'll say we'll start the position at here, right? If we want to start the position at here, means we'll start here, right? Or we can say for now here, right? So we'll check it is pointing to the next available cell or not. Do we have the next cell? We don't have a next cell, right? What is the next cell? Next cell is for this one, right? So this could be either the right side or the bottom side, right? Let's suppose for this case, when we reach the upper directions, right? So we'll say this is the right directions for this, right? In the right we have the what you call, we can say the element, and when we reach here we can say we have the another element, right? So when we reach here we can say that we have another element which is at the bottom, and we can start from here top. Then we'll go again, we'll say this is at the start, this is at the right position. Or you can say sometime it can be along the path, right? There can be multiple elements. So in this case, the upward, downward, right, we can say. So each cell we have to check, we have to point to the next available cell. The next available cell is either at the bottom, right, or along the edge. So when we change the direction, let's say 1 after each bounce, we have to do that. I hope you understand, right? So let's understand how to implement it. Okay, so very first, this is the base conditions, the edge cases that we have to check, where we'll check if matrix is equal to 0, right, and its length is 0, we'll return the empty one. Okay, other than that, you have to find the n and m, right, the row and column we have to find, right, and we'll assume that will initially, because we have to prepare the diagonal order, right? So for that we will create the row and 0 that we will start at from 0. Okay, and then we'll go for the direction. So each time we'll have a flag that is called direction, and we'll flip the flag once we rotate the directions. Okay, so or we can say flip the direction. So we'll create a result with the same n cross m matrix, so all the element will fit here. Okay, then we'll take the r, and r will start from 0. Okay, so let's suppose we have a while loop, right, and we'll start from here. We'll go for all the elements, and for that we'll say row is less than n and less than, yeah, so we'll go for all the values and we'll not go for the out of the bound, right? Very first we'll initialize the result r plus plus, so each time the result is the resultant index, we can say, and we'll increase the row and column values from here. Now we have to take the new row and new column, right? So for this case, let's suppose we have the row, and we'll say the direction. What is the direction for each row? Okay, so we'll initially row we have to take, we will take from the 0, and so we'll say if direction is equal to 1, means we are going for the upward directions, right? When we are going for the upward directions, we'll say do not if it is this, right, we have to take the new row, right? And that time the new row, if this is this case, so we'll say new row is -1, right? If this is not equal to, we'll assign 1 the next row. Okay, so let's suppose very first row we have is whatever we'll call it as a 0, right? So we'll do the minus will increase in this one, that is called new row. Similarly, we'll get the new column, right, and this is the upward directions, right? For that case, so you will get the new row. Similarly, you will get the new columns, and you will check the direction. If this is the upward directions, in this case we'll reverse it. If the direction is this, so we'll say we'll take the column, right, and this time column will become 1. Okay, why we are going to do, let's understand. So let's understand what is this new row and new column. Okay, and how we are going to calculate. Very first, this new row and new column, we will take this variable in the diagonal traverse algorithm, right, that we are going to use to calculate the next cell position, right? So while moving diagonally, if you remember how we used to move, right? So if this is the matrix we have, can we say that? So we used to go first this give me a second. Okay, here, let's suppose call this way. Okay, when we are going to calculate the next cell position. So very first we started from here while moving the diagonally. So either we'll go the upright and downward, that you know, either this is upward and this is your downward. Sorry, it is touching this one, so we'll say like this. Okay, now fine, this is your upward and downward, and we say that. So when we are going upward right, and down left, so these two way we have to move, because we are going to diagonally, right? So before actually moving there or handling any boundaries, let's call we have seen some couple of videos, sorry, couple of values. Let's suppose, what was that? If we'll write the value like this, let's call this value was, I think, 1. Let's start like 1 2 3, then we'll say 4 5 6, and this is your 7 8 and 9, and we say that. So when we have this value, okay, so when we move diagonally, that we are talking about. Let's suppose when we are only moving the upward right and downward left. So before actually moving there, we have to handle the boundaries condition. Let's call 7, 6 and 4. So this is your 7. One second. This is your 7, right? This is your 6 and this is your 4, correct? Because if you remember, very first we got this one upward, then we got the downward. When we go the up right, and when we go to up down left, right? So when we reach here, we got the boundary condition at 4. Again, we'll start from here and we go upward directions, right? Like this, correct? So when we'll go upward directions, right? From where we'll start? At 7. Then we again from here we have to come back and we have to go to downward directions. Can we say that? Other than the 1 and 2, right? So this will also go up or leave it. But if you remember, when we go downward, we go till the 4, right? The boundary conditions that we have to handle when we are moving, right? Before actually moving there, we, until we are reaching the 4 and 7 and 6, right? So before moving, actually there or handling the boundary condition for these cases, right? Can we say that? So that is why the new row and the new column we have to take, right? So how they will work, let's suppose they represent the potential next position if you are continuing along the uh, current diagonal directions. Let's suppose we'll call out the upward right when the direction is equal to 1. So when we are going for the upward directions, right, means we are taking the direction equal to 1. So what will happen for the new row? New row equal to row minus 1, correct? When we are going from here, right? Let's suppose, let's talk about this one, right? What is the new row? What is the new row? Equal to row minus 1. How? Let's suppose I want to calculate the new row. Currently we are at row 0. Okay, so row 1, we can say row 1, and this is row 0 and row 3, 1 2 and 2. This is column C1, C2 and C3. Can we say that? Or C0, C1 or C2, we can say. That's better. We assume it as index also. Okay, so when we add 4, right? So this is our conditions, right? So when we want the new row, right? New row will start at where? What is the current row? Current row is 1. We'll take minus 1. So new row in this case it will become 0. Understanding? And that is why if you see here, we have taken current row, right? The row that will have is 1, and will, when you say direction is equal to 1, means we are talking about the upper directions, and happening minus 1. We'll do the minus 1 and you will get 0. Understand? Now talk about the new call, right? So when we talk about the new columns, right? So we say new call or new column leaders. Okay. When we talk about the new columns, then what will happen? We have to take the, here we are taking the row minus 1. It means we have to take here column plus 1. So we have already taken the row and column here. So current column is nothing but your is what? Is 0. We will say 0. So we want 2. To get the 2, we'll just do a 1. Means we are talking about 1. In this case, it will become the 0 and 1. At 0 and 1, what is the value? At 0 and 1, value is 2. Correct? Because we wanted to get the 2. From 4, we wanted the new value. What is the new value? For the new row, new column is 2. And so we'll get that value. I hope you understand. Similarly, we'll try to go for all the edge cases, right? So the new row and new column should not exceed less than 0 and should not reach to the n. Understand? Means they are the row where we should not go out of the bound from this case, and it should not go beyond the this condition, means from 0 to n it should not cross. So you should have write the conditions so it will not fall out of the bounds. Okay. Then for each directions, you have to calculate the columns, right? You know that if direction is 1, you have to prepare your column. The current column we have to also update row and column. So this case, you will check the column. If equal to m minus 1, you will increase 1. If you'll check column is less than m minus 1, will increase 1. Both cases you have to take in these cases. Similarly, you will try for in the other cases for the flip position when it is going for the upward directions and when we are going for the downward directions. Okay. And each time you have to update the flip, this you have to flip the direction where we are going for the up and down, right? Either of the position up, either you are doing here or here. After each position you have to flip it, and then you have to call the row equal to new row and column equal to new column. Means we have to get the new row and new columns, right, for each value. And then means we have to reset, you can say, and then we have to uh, return the result. Okay, I hope you will like this video. If you have any doubt in this video, please hit subscribe the channel and let me know in the comment section if you have any doubt. And thank you guys, thank you for watching this video. I'll see you in the next one.